audio was not clear, so I am making the video again. So I am making the video again regarding the question of regarding to the pulley. So the question was, we have a pulley connected with both masses, one mass small m, the another mass capital M. So the mass capital M, in this question it is given that M is greater than small m. So you can see the question on the screen. On the screen the question is there. This capital M has more mass and the small m has the lesser mass. So if you consider the more mass will pull the smaller object towards above, this will go upwards and this will go downwards. Why? Because the mass is more and the weight of this object also will be more. Okay, so weight will be acting towards the downwards direction. For this object it is capital M into G, and for this object it will be small m into G. Now as this object is pulling the object towards the upwards direction, so the acceleration of this mass will be towards downwards direction and the acceleration of this mass will be towards the upwards direction. Now what we need to do, we need to find out what is the tension acting on the string and what is the acceleration acting on the string. So first of all, what is the tension? So if you consider this mass, the mass of the object, that is the weight of the object also we can consider. The weight is pulling the object towards the downward direction, therefore the tension of the string will be towards upwards. Tension is a force acting on the string. Similarly, this weight of the capital M is acting towards downward direction, so the tension will be acting towards the upwards direction. So we need to find out the acceleration and the tension. So let us find out how to do it. Suppose for mass small m, total force acting on it will be F m will be equals to total force acting on it. If you consider here there are two forces acting, one is a weight mg and one is a tension, and since the body is moving towards the upwards direction, here the force which one will be greater, here your tension force will be greater. Okay, and the gravity is acting towards the downward direction, so we have to write as T minus of mg because both are acting in opposite direction. Why I have taken T first? Because the object is moving towards opposite direction. Similarly, if I consider the mass of this, mass into acceleration, T minus of m into g. Okay, so we have got the mass into acceleration is equals to T minus mg. So similarly, if I want to calculate, suppose if I mark this as equation number 1, let us go for the equation. So for mass capitals M, it will be capital Fm will be equals to T minus of m into g. Sorry, this will be not T minus mg. Here there will be a difference because the object, the capital M object is moving towards a downward direction. So the acceleration, as you can see, it is towards a downward direction. Okay, that means the weight will be more than the tension force. So we have to write in this way, capital M into G minus of T, or we can write MA will be equals to mg minus of T. Mark this is equation number 2. After this, you add equation 1 and equation number 2. So if I add equation 1 and 2, equation 1 plus equation 2 if I add, will get as capital M plus small m. It is, I have taken A as common, left hand side, then T minus of mg plus mg minus of T. So your T and T will get cancelled. Then it will be G m minus of small m. So if I put A this side, so G m minus of m divided by m plus m. This is equation number 3. So we have got the acceleration of the object. Okay, so what is the acceleration? We have find out. Now we need to find out the value of the tension. Put the value of A in suppose in any of the equation. I will be putting in suppose equation number 1. Putting A in equation number 1. So it is MA is equals to T minus of mg. So M A we have got G m minus of m divided by m plus m is equals to T minus mg. We need to find out the value of tension. So for finding out the value of the tension, put T here this side, then put the other terms. Okay, put the other terms like T will be equals to small mg plus, if I multiply this part, we'll get as capital M small m into g minus of m square into g. Okay, divided by, it will be m plus m. I multiply this whole part, then it will be, if I cross multiply, so it will be m g plus m square g after taking the LCM, plus it will be m into g minus m square into g, divided by, it will be m plus small m. So here your m square g and m square g will get cancelled. So what will be left out? So after doing it, so T will be equals to capital M small m into g. So it will be 2 mm by mmg divided by m plus m. So this will be your answer for the tension. So we have got the value of the acceleration also, we have got the value of the tension. So this is a question that we have in which the audio was not clear. So this is regarding that question. This is regarding a problems of a pulley. There are many questions related with this in the NCERT book. You can try that some questions also from the NCERT book. Okay, so we'll be moving to the next part. So our next part is about that Newton's second law is a real law of motion. We need to prove that. So Newton's second law is a real law of motion. Why it is called? Because we can derive both the first law and the third law from the Newton's second law. Okay, so let us find out how to do it. Number 1, first law is contained in the second law. Okay, how? According to Newton's second law, what we can write? F is equals to mass into acceleration. This is according to Newton's second law. If we consider that if there is no external force, if there is no external force, okay, no external force means F is equals to 0. So if I put F is equals to 0, then what will happen to this? 0 will be equals to mass into acceleration. So here we know that mass not equals to 0, mass कभी भी 0 नहीं हो सकते, then acceleration will be 0. So what is the meaning of this? This means that this is regarding the statements of the Newton's first law. This proves that a body at rest will remain at rest and a body in motion will always remain in a motion until and unless an external force is applied. Because you have not applied any force, so you have got the acceleration is equals to 0. That means your body will always be at rest if you don't apply force from outside. Okay, or your body will be moving with a uniform motion. So we have got the acceleration, because you can see, because acceleration formula we have v minus of u by t. If your body moves with uniform velocity, so v and v will be the same. So what will happen? Your acceleration value will be 0. So this is regarding the statement with the law of inertia. So hence we have proved that, the Newton's first law is contained in the second law. Okay, so below you have to write, that this proves that a body at rest will remain at rest and a body in motion will remain in motion, which is the statement of the first law of motion. Therefore, first law is contained in the second law. So that you have to write. Okay, listen it again, then you write it. Then I am moving to the next part. That is the third law is contained in the second law. Number 2. That third law is contained in the second law, so we need to prove that. Is contained in the second law. Again we will be starting from here only. Then according to Newton's second law, what we have? according to Newton's second law, we have force is equals to rate of change of momentum. Suppose if I consider that we have a table. Okay, this is our table and I have kept a book above it. Okay, I have kept a book above it. So when you keep a book above it, so your book will be applying a force on the table, and similarly your table also will apply a force on the book. That is the action and the reaction force. Okay, that means suppose if I consider that your table is object number 2 and your book is object number 1. So force applied on the table, force applied on 2 due to 1, force applied on 2 due to 1. Similarly, the table will also apply force on the book. So we can write this as F1, 2. Force applied on 1 due to 2. That means force applied by the table on the book. Okay. So if I use the Newton's second law, we can write that F1, 2 will be equals to dP1 by dt. Similarly, I can write that F21 will be equals to dP2 by dt. Okay, dP2 by dt. Same, if I consider here, if we consider that dP1 by dt and dP2 by dt. Okay, if you consider this one, same way if I consider that your system has no external force applied on it, that means there is no external force applied on it. So what we can write? So by adding these two force, F12 plus F21, what will you get? You will get as dP1 by dt plus it will be dP2 by dt. Okay, now if there is no external force acting on it, if there is no external force, that means your total force will be equals to 0. That F12 plus F21 will be equals to 0 because there is no external force acting on it. So if F12 is equals to F21, we can write here in this way, F12 is equals to minus of F21. Now you can see, this is your Newton's third law. F12 is equals to minus F21. Okay, F12 is equals to minus F21. Have we got from the Newton's second law? Where we were using Newton's second law, but when we use the statement that there is no external force, we have got that F12 is equals to F minus F21. This is your action and this is your reaction. So this is your Newton's third law of motion. So we can write that this proves that Newton's third law is contained in the second law. So we have seen from the first law and the second law that the first law and the second law both contained in the second law. So Newton's second law is a real law of motion. I am repeating the statement again. As both the first and the third law is contained in the second law, so Newton's second law is a real law of motion. That you have to write as a statement after proving this. Okay, after doing this. Okay, so this much for today. So in the next class we'll be discussing some more topics related with the laws of motion. Thank you.